This training series is sponsored by Hackaholics Anonymous. To get the supporting materials for this series, like the 900-page slideshow, the 200-page notes document, and all of the pre-made shell scripts, consider joining the agent tier of Hackaholics Anonymous. You'll also get monthly Python automations, exclusive content, and direct access to me via Discord. Join Hackaholics Anonymous today. Okay, so we are now in the process information and monitoring section. And for pretty much for the most part, I feel like most of these commands we've actually covered at the very, very beginning when we were dealing with getting system information and kernel information and things like that, because these commands actually do overlap. So for example, the PS command that would list all of the processes. So for my particular session, I only have the PS command that's running as well as the shell that's running. So if I did PS aux, it would give me everything historically, all running processes with the detailed information. And these are everything that's also running in the background as well as everything that's currently running in the foreground. So what we did with PS, it was just showing me the stuff that's in the foreground, for example, this shell window that we're in right now, as well as me running the PS command. But when you do the PS aux, it shows you everything, including the stuff that's running in the background. And then we also have the PS-EF. So this was one of the commands that will give you a different format, and it's the full format listing for everything that's available here. And it gives us the user that's assigned to it, gives us the UID the PID that's assigned to it, as well as the PPID, so the parent process ID that's also assigned to it, and then the time that it was launched and running, and then the command line entry for being able to access to any of those things. We will get all of that with the EF command. So it shows you everything, all of the processes with full format listing. And then we have everything that can be assigned to any given user. So if I wanted to do all of the processes that are for Bill, I mean, there is no user for Bill because we deleted Bill. But if I did PS for the user Callie, it's actually going to show me everything that's available for the user Callie, which is the current user that I'm logged in as. And again, it shows me all of the foreground stuff, which is ZH for the shell, for example, as well as systemd, which is a background. And then let's see if we can find Zoom. There we go. We have Zoom on here because Zoom is technically recording. And let's see if we can find Firefox in here as well. So it's under web content. So it probably would be Mozilla maybe, or the agent. So I can actually try to grep it. So since we already know that we can do that, so let's say user Callie, and then we can grep, let's say ignoring the case insensitive, we can do Mozilla, and nothing is available for Mozilla. So let's see if we can do Firefox. And there we go. So there we got it. We got Firefox in the list of our processes for the Kali user because we actually do have Firefox open and it's sitting somewhere in the background right now. So that is how you can check for the processes that are running inside of your system to see what's actually running. Now, probably the first one that I should have covered with you was the top command. And again, we've also gone through this. So the top command will show you all of the top processes that are running, and it's going to update it for you by default. It's going to update it every 1 second. So you can see that the list is changing frequently. And so you can, we went through a lot of these potential options to change the increment of how frequently it updates. So you can change it from every second. You can change it to every 5 seconds, for example. You can change it so that you only view the processes by a given order. So for example, we can modify the order that these things are actually displayed in by, let's say, memory, right? You can modify the order that is displayed in by memory. You can modify the order. There's so many different versions that you can modify for us. So I'll kind of give you some of those reminders of what we looked at looking at the commands here. So we have top, and then what it does is all the stuff that we can do, for example, giving us the sort by CPU usage would be holding down the shift button and then pressing P, and then you can see CPU, so processing power. This is now updated, and even though it updates every second, it still is organized by the CPU usage. If I wanted to organize it by the memory of the RAM, I could just hold down the shift and then do M to sort by memory usage. If I wanted to sort it by the process ID, I can do N, so hold down shift, so capital N, and now you can see that it's updating everything by the process ID. So this is the top command. It gives you everything that's currently running. And for the most part, what you're actually really interested in is the processing power as well as the memory. You want to know which processes are taking up the most resources on the computer for the most part, because usually those are the ones that you need to be aware of because they either are just eating up too many resources. I've read about instances where somebody hacked into a computer and installed a crypto mining software, and it was running in the background for a long time, and the person wasn't aware. They just knew that their computer was slowed down, and they're like, why is my computer slowing down? And then you would run top to see what is actually taking up most of your processing power, so your CPU power as well as your RAM power. And then you look at it and you're like, oh, I don't even recognize this. I have no idea what this is. And it's taking up the bulk of my RAM and my CPU. So I need to find out what it is. And then you do further investigation and you find out, oh, somebody installed a crypto mining software. So that is that's what top is very, very useful for. So let's say you actually have found out what it is and now you want to kill it, right? So if you do K, it's going to ask you, so give me the PID that you want me to kill. Now, in my case, I don't want to actually kill anything. I don't want to kill any of these processes because I'm using every single one of them for this tutorial series. So I'm not going to kill anything. But you just do a lowercase k and you press K and then fine. Boom. All of a sudden it's going to ask you, okay, well, what do you want me to kill? And then immediately you just go ahead and do that. Now, the default PID, if you notice, is the very top one because this is the first one and it's the one that's actually using the most processing power. So let's say we change our and we go by N. So if we do, actually, I don't want to do that. So let me escape out of that. And I'm going to sort it by N, meaning the process ID number here. And now they don't actually should take a lot of CPU or processing power. So if I do K, it actually does pick the very top item as the default choice. So we need to keep that in mind that it's just going to by default choose the very first item. It doesn't matter if it's been sorted by memory or CPU or anything like that. It's just going to kill the first item that is on its list, right? It's going to kill the first item on the list. So we can just escape out of this by pressing escape. And now we're back in this case. And now we want to get out of top. So we're just going to press Q and then we're going to get out of top. And just like that, we learned how to look at the real-time processes that are running on our particular computer. And again, I'm not going to go too deep into this because I spent a lot of time explaining what top does in the very first section under system information and status. And then it was under the process details and finding process IDs section. So we're not going to go too deep into that. And then another command that's over here as well is the what is it? The excuse me. It is the htop command. So the htop command is just a human readable version of top, and I'm not going to install it right now because it's really unnecessary for us. I never showed it in the first version, so why not? Why not? Why don't we actually install it? And then we can go ahead and run it and see what the input or the output of that will look like. So there we go. This is what htop looks like. Not bad, right? This is the user-friendly version of top, and everything is color coded. The bars at the top are much more user-friendly. So this is another version of this that you can essentially just look at what's going on inside of your system and then see which one of these things are taking up the most amount of memory or the most amount of space. So let's see if the same shortcuts work. So if we do capital M, for example, it does actually sort it by memory, and we can see this little drop down right here. If we do capital P, it'll sort by processing power. If we do the capital N, it'll sort it by the PID. So we can see it over here. So it's actually very useful. I like the fact that there is an input output that I can click around here and I can look at the various processes that are running. So I should have just done this for the very first section. But if you've made it to this portion, you got this as a reward because we are definitely in the latter half of this training series. So I am actually kind of proud of you. Not kind of, I'm actually really proud of you for making it this far. And as a result, as just kind of a little reward for you making it this far. I wanted to show you what it's like to look at the interface for htop. So htop pretty much gives you the same data that top does, except as you can see, it's much more user-friendly and kind of nicer on the eyes to interact with. So we are going to now escape out of this, and we're just going to press Q, and then we are out of htop. So there is that. So now we've covered everything for getting the information about processes as well as monitoring. So the next thing that we want to talk about is how to terminate a process. So by default, right, if you wanted to look at, if you wanted to just kill something, for some reason, there's something about that that really amuses me. If you wanted to kill something, if you press kill just by itself, it's not going to give you any arguments. So what you need is to actually, you need to have some kind of a process ID that's associated with it. So if I do kill and then give it the process ID for shell, for example, let's just do that. Press enter and it should kill it, but it's not going to because we're inside of it, and it's not going to force the killing of that. Now, if I wanted to kill the process based on its name, for example, I could actually do a pkill command, and now I would need to give the name for the attribute for the process. For example, zsh, and it would kill the process named as zsh, but still it's not going to do it because we're literally inside of it. So we're using it, so it's not going to kill it. You would have to force kill something, right? The force kill, or if we wanted to kill something, we could say kill dash L, and it should give us all of the stuff that we can potentially interact with and kill. And for whatever reason, I would say that it says list all of the available signals. That's what I have in my notes. So these are all the available signals that are available for kill in this particular instance. And really, if we wanted to forcefully kill something, so let's actually try this. So if we wanted to forcefully kill the process of shell that we have over here, we would do kill and then give it the 9 option and then give it the PID, and it still didn't forcefully kill it. So I guess it doesn't, or maybe it is kind of, it's kind of running in the background. So I guess it is killing it. It just killed it because now I can't run clear or anything even remotely close to that. So I guess it did actually forcefully kill our shell instance. So I'm going to close this out and I'm going to open up another one, and then we're going to start from the very, very top here. So that was kind of cool. We were able to forcefully kill it. It didn't close the window. I thought it was going to actually close the window. It didn't close the window, but it did end the process from actually working. So that is what it did just for the one process that we had over here. So that is kill. And then we could do the same thing with pkill to actually do it by its name. So it would be zsh in our instance, and then it would kill the process by its name. You can also just look at, you can kill all of the processes for any given user by doing pkill and then give the u option and then the username, and then you would kill all the processes by user. So let's say you want to kick somebody out of the system and you don't want them to be able to do something, or you feel like their computer has been compromised and you want to kill it, you can just go ahead and kill it by the user by just doing pkill and then the username, and then we can do pkill F, where we can kill all the processes that match any given pattern. So in this case, it could be a specific regular expression pattern or something that, for example, would be this dot ZSH, for example, or something along those lines. You can give it a pattern. So if you do pkill, you are not going to be interacting with PIDs. You would be doing the process name. So you would be giving the name of the process that you want to kill. And then finally, you have the command, which is kill all, which is a little bit of an interesting thing. It doesn't kill all of the processes, but it will kill all instances of a process. So let's say you have 25, Google Chrome windows open, or you have a bunch of web browsers open, and you just want to kill all of the processes of the web browser because it is taking up so much of your RAM, and now the computer is slowed down and you can't even compute anything else because your browsers are taking up all of your CPU and RAM usage, right? Or you found something malicious that you want to kill all of the instances of that malicious process, then you would do the kill all command, and then you would just need to give it the process name, because in this case it's not going to work with a PID because most likely the same process can have multiple PIDs. So if I have multiple Chrome browsers open, each one of those browsers is going to have its own PID. So if you wanted to kill everything, you would do kill all Chrome, for example, and it would kill every instance of Chrome that's available. And if for whatever reason it's not working and it's taking a lot of time to do it, you can forcefully kill everything, kill all the instances of Chrome by doing kill all dash 9 and then giving it the process name. And then in that case, it would kill all of the instances of Chrome, for example, forcefully, manually, just forcing you to crash. And you would have to probably send kind of an error report or something the next time that you open it up because you forcefully killed it. So this is how you interact with these processes and get rid of all of them by using the kill command. All right, now we want to talk about scheduling and the automation of tasks. And the way that we can do that is with something called crontab or cron jobs. And then as well as there's another tool called at. So at is actually a much simpler version of it. So what I'll do is I will actually run this little command right here. So we'll just do echo, I will do echo, hello, Callie, and then we will do it at, so this is actually how it works, and we will do it at, and then I can do, what is it? My current time is 2:07, so we'll do 2:08, and then we'll just press enter, and then hello Callie at 2:08. Oh, wait. Oh, you know what? I'm supposed to pipe it, so my bad. So we're going to do echo hello Callie, and then we're going to pipe it, and then we're going to do at 2:08 and press enter. At has not been found, but it can be installed with sudo apt install at. So let's actually do sudo apt install at. And now it's going to install it. Do we want to install it? We do want to install it. Very good. And it should be all good in a few seconds. But basically, it's like a very simple version of running something at any given time. And it does it fairly simply because you don't have to worry about creating a cron tab or like an actual scheduled task. So I'm going to do this one last time here and do 2:08. Commands will be executed using bin shell job da 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 da. Okay, very cool. I mean, I'm already at 2:08, so maybe now I need to do this. Let's see if we can do it with like doing now plus 3 minutes or something like that. Actually, we can do that. So we could just do this, and instead of doing the given time, I could just do now plus 1 minute. And then I'll just run that. And now it says command is going to be executed using the shell job 2 at Tuesday, December such and such at 2:10 in the morning, because right now it is 2 or it was 2:09, but now it's going to, or it was 2:08 when I created this, and now it's going to be 2:09. That's where we are. And then at 2:10, it should just say hello Callie, and it should just echo it onto my screen for me. And that's one of the ways that we can do scheduling. Okay. So the other way that we can do scheduling is by looking at our cron tabs, which is basically our actual scheduled tasks. So the location for that, and I'm not going to type anything for at least the next minute, just to get that scheduled task for you real quick to pop up that we did with at. And then after that, we'll go and look at the cron tabs file and what all of the scheduled tasks actually look like. All right, unfortunately, that actually didn't work. So that's kind of anticlimactic for me. I did get the notification. I mean, when we ran it, so if we do this one more time, add now plus 1 minute, right? So if we do this and it says it's going to run and it's going to run at 2:13. So that should be fine. And then there's a way that I can look at my scheduled task so we actually see it, right? So we do have a command that's listed here. It's job number 3. It should have been, it should run, but for whatever reason, it didn't actually run it. So commands will be executed using bin shell. I mean, that's where I am. I would expect for it to actually run and for it to actually be executed, but for whatever reason, it was not doing it. So now I'm a little bit disappointed at the fact that at didn't work. So at least we tried it. And what we can do if we wanted to really, really like kind of result, kind of bank on the result that this is actually going to work, we can now move into cron tabs because cron tabs for a fact will actually work because they are literally this scheduled job. So the way that you would look at the current list of the cron jobs for our given user, for example, I would just press this and then there's literally nothing here because I don't have anything that's been scheduled. So I can now open up my crontab file and this is what we have over here. So since there's no crontab for this person, we're going to use an empty one. So select an editor. Do you want to do nano, Vim, or Vim tiny? So I'm going to do nano because nano is my favorite. And now we are inside of the crontab file. So very, very simple. What you can do is you can essentially add anything. So I wouldn't mess around with any of these comments that are over here. These are just instructions that will give it to you. And what you see over here is a sample in this particular case that says you can run a backup of all your user accounts at 5 a.m. every week. So this is what you're looking at in this case. These portions right here is the time that is being assigned to this task. So the first one would be the minute. So you can do 30 minutes, right? So if you do 30, it would be every 30 minutes. The next one is the hour of the day, right? So 5 in this case is representing the hour of the day, and it's very similar to military time. So if you wanted it to run at 1 p.m., you would give 13 in this situation, and that would act as 1 p.m. So it's the hour of the day, the time of the day, okay? And then you can do the day of the month. So if I do 1 right here, that would be the first day of the month. If I do 10, it would be the 10th day of the month, so on and so forth. Then you can do the month itself. So if in this case, I could do month 6, and that would be June. And then finally, the day of the week, which in this case is 1, and that represents Monday. So every week it's going to start on Monday. So it's going to do this 5 a.m. every week, and it's going to run the actual command itself, which is this command right here. So you give it the time or the schedule that you want it to run on. And then after that, you would give it the command that you want it to run. And in this particular case, it's going to use the tar command, which is the command that creates archives. And from there, we're going to use these various options that go with the tar command. And then we're going to back up this location, or we're going to back up, excuse me, we're going to back up this location, but we're going to back it up into this specific backup file, this archive file that we have in the var backups, and then that's going to be the tar zip file that has been generated using the tar command. So this is basically how you can generate some kind of a scheduled task inside of Linux. Now, for Windows, for example, it's so much more user friendly because you can actually go and create a scheduled task with a point and click type of environment. But for us, we have to learn how to do this inside of the cron tabs document. So as an example, we can essentially, let's say, if you didn't want to run tar, let's say you have a script. Okay, so let's say you have a shell script, and I don't have one, so I'm just going to pretend like we have a shell script. Okay, and we want to run the shell script at 5 a.m. every single day. Okay, or let's say 10 a.m. We want to run it at 10 a.m. every single day. So you can see down here we have the minute, we have the hour, we have the date of the month, the day of the month, excuse me, the month itself, and then the day of the week. And then next to that, you would have the command. So you can just do this as it goes like this. So you have 0, which would, or actually, excuse me, not 0. Technically, I guess we can do 0, right? We could do 0, which would be no minutes necessary. We're going to do 10, which would be the hour of the day, so 10 a.m. And then it's going to happen every day. So that's how we imply every day. So it's going to not, it's going to be 10 a.m., no minutes necessary for it. So this is the minute, this is the hour. Day of the month doesn't matter because I want it to be every day. Month itself doesn't matter because I want it to be every day. And the day of the week doesn't matter because I want it to be every day. So that's the schedule that I've created for this. And now let's say I have on the home Kali desktop location, I have a backup.shell, right? So I just want you to run this. And that's basically it. When you are running a shell command, you just need to provide the location of the shell command and then it'll run it. If I wanted to do something else, if I wanted to actually run a command itself, I could do sudo and then I could do UFW and I could do delete, right? Whatever. And then we would give it the the first rule that we wanted to delete, and then it will delete the first rule. So you basically just assign the command that you want to be run or ran at whatever this scheduled time is. And that's how you modify the cron tabs document, the cron jobs document. And it's for my specific user that I'm logged in as. So just keep that in mind. This is not going to apply system wide or anything like that. It's specific to the user that I'm logged in as. And that's basically it. It's like a very, very simple script to run. We're not going to save this, but I do want you to see that there is a manual for this. And then you can go and check this out as well. And for the most part, it's going to repeat what we have inside of that initial instructions that we saw at the top of the file. But there's a lot of different ways that you can look at it. And I mean, what did we have? So highlighting the output of the cron tab L, Debian specific rules, and everything else for the description of what it actually does. And then you can just look at the help menu. You can look at the user itself, as well as the file that they have, and then everything else that comes along with it. Crontabs is a very useful tool. You will probably also end up doing this as a Linux administrator, and it goes kind of, it would be ranked in the same level of importance as learning how to do the configuration of IP tables, for example. If you know how to schedule tasks, if you want to create scheduled tasks, if you know how to do that, then you will, again, kind of stand out from the rest of the environment as far as your competition is concerned. So that is what we have for creating scheduled tasks with the command of @, which unfortunately it didn't work. I'm just going to try it one more time actually, because I don't know why that didn't work. I was like so excited for it to work and just print this onto my screen, but now it's just kind of bugging me. So I'm going to run this and then we'll wait for a minute before we move on to the next thing. Maybe it's because I cleared the screen or something like that. I don't know, whatever. We'll see. We'll see if this time it actually runs. And if it doesn't run, then I'm just going to move on to the next section. But that's basically what we had. We had the command that we learned that was useless. And then we have the cron tabs command that we can modify the cron tab file and create scheduled tasks. And that's all we got for that. So the next one after this works or does not work is going to be the process priorities. So setting priorities for a given process. Okay, so this thing did not run, and I am officially not a fan of the command. I just wanted to share it with you just so you know what it actually is, just in case you run across it. But for the most part, it's pretty useless. All right, the last piece that we need to cover inside of the process and job management is the process priorities. So setting priorities with the command called nice. So nice essentially establishes a priority of a given task based on what you think is important in your system. And you specifically assign this to tasks that are resource intensive. So they'll take up a lot of CPU usage or a lot of RAM usage. And it basically modifies the scheduling priority. So if you give something a high value on nice, that means it has low priority. If you give it a low value on nice, that means it has a high priority. So it's kind of one of those things, right? So when you run it with a low priority, you're giving it a high nice value. So for example, let's actually go and kind of look at this. So if we were to look at, for example, I don't know, whatever. We'll do first of all the value itself. So we can do a low value or a high value of 15. So we've given it a high nice value, which means that this is low on the priority list. I know it's kind of confusing, but it's kind of how the whole thing has been set up. So it's a higher nice value means that it's a lower priority. And then after this portion, we are now going to assign the command. So it could be sudo chmod plus, x of the file.txt, for example. So, and this is like a very low resource use command, that's changing of the permissions of something, but this is kind of just to show you what the syntax looks like. You essentially assign the priority level with nice, and then you will give it the command, and then it'll just kind of do what it does. And so what happens is when you have a resource or when you have a command or a tool or a process that takes up a lot of computer resources, system resources, What you want to do is you want to make sure the rest of your computer doesn't stop working because there's this one specific process that's using up all of your resources, all of your RAM and CPU power, for example. So you would assign it a high nice value so that the rest of the system can actually operate. The rest of the system can actually function. And when you do that, then it'll still run this command that we have on the screen or whatever the big command is. It'll still run it. It just won't run it at the expense of everything else that your system needs to do to operate. So it'll kind of run it with a less urgent priority so that the rest of the system can still function. And that's what nice means. Now, if I did nice 0 or nice 1, let's say, if I did nice 1, nice N1. That means this is a very high priority. So I want you to do this first. You can kind of think about it like that. If it has an N level of 1, that means I want the system to run this first. It's the highest priority command. And then you would give it the command after the fact. And then it would run that in the first level of priority. If it was a level of 15, then it would run it at the 15th level of priority. So it's not first in line, it's 15th in line, so to speak. You can think of it like that. So that's what nice does. Now there's something called renice, which means that you can essentially change the priority of an existing process, that's something that's already running. So let's say you did nice and 15 for the command here, and now you can see that your system resources have freed up, or maybe this command is now more urgent. So if you wanted to change the priority of this command, you would then use renice, and then you would give the value to it. So in this case, it would go from, let's say, the process, let's say 10, for example. It would be not 10, excuse me. So I think there's no n value to it. It would actually, so let's look at the manual. Let's see if we have a manual for renice, and we do. And let's see. So if no n priority or a relative option is used, then the priority is set as absolute. So n and then the priority would be the absolute or relative depending on the environment variable, so on and so forth. So we still do give it the n option to be able to make it run. So we would do very similar to what we did. So if it was again, so if we had nice and 15, and then there was the command, which means now it's 15th in line. It's not a high priority command, and I want to upgrade it. I would do renice and I would give 5 to that command, and now I've changed its priorities, so now it's more urgent to run this command. So the system will dedicate more resources to it, and it will make sure that the command actually is complete and it gets done. This is a very interesting series of commands. I actually was not even aware that these things existed until I started studying for Linux Plus, and I've never used it in real life. I just noticed that it is available, and if it's, I think, in an environment that's very, very limited on resources, or if it's in an environment that there are so many processes that are running that is eating up all of the system resources, then you need to kind of reorganize the priority level of all of those processes by using the nice command or the renice command. And you can even do this for the processes of a given user. So you can do renice and then do n and then do 5, for example, which would assign a level of 5 to the user Kali. And it would be all of the processes that belong to that specific user have now been assigned a renice value or the priority value of 5 instead of, let's say, the Kali user was at 15th in line, and we wanted to make sure that all of their value gets done or all of their processes get done. Or it could even be the fact that maybe the value for the Kali user was at 2, so there was very high priority, and it was just taking up a lot of processing power, and we want to move it down to 5, or we want to move it down to 8, then we would do that, and then we would give the user Kali, and then all of that specific user's processes, all of their tasks that are currently running, it would just be moved down in priority, so the system will not be exhausted, and we won't use all of the resources of the system. So that's the difference between nice and renice, and essentially the purpose that they serve, which is establishing priority for something or changing the priority of something. And that's basically all we got for our processing, getting the information about processes and job management, and then scheduling jobs and processes, terminating them, and of course, setting their priority. So that's what we got. And now we can actually move on to the next section, which is going to be system monitoring and logging. This training series is sponsored by Hackaholics Anonymous. To get the supporting materials for this series, like the 900-page slideshow, the 200-page notes document, and all of the pre-made shell scripts, consider joining the agent tier of Hackaholics Anonymous. You'll also get monthly Python automations, exclusive content, and direct access to me via Discord. Join Hackaholics Anonymous today. Okay, so let's go into system monitoring and looking at the system and kernel logs. So there's a big section for incident response investigations, troubleshooting, and everything along those lines, because logs pretty much store everything. And if you're looking at, if you want to monitor the system in any capacity, your authentications, your system processes themselves, the connections to the internet, and everything along those, literally anything between, or just anything that you want to look at, it's going to be all stored in the logs. Now, what's going on with Linux is that there are a few different locations where we have logs stored, and we've kind of already gone through this. We definitely went through it in depth when we went inside of the lecture for this training series. But for the system itself, so there's something called the initialization services, the init services, and for system D, which is the init service for the most recent versions of Linux and the most recent distributions of Linux. There's something called journalctl. Journalctl just by itself, if I press this, I'm pretty sure it's going to give me a lot of output. So we'll just try it. And there we go. We have a massive amount of output that's available for journalctl. And this is line 121. And then you can see that there's a lot. So I'm pressing right on my keyboard and it's giving me a lot of data. Now I press down and it's going to take me 2 of 22, 3 to 23, so on and so on. And it's just going to keep going. And there's a lot of stuff because this is a journal of everything that happened inside of the kernel. And at the bottom, I don't know if you could see it, but the numbers are updating. And we are now in the 200s, and in just a few seconds we're going to be in the 300s, and it's just going to keep going and keep going and keep going. And journalctl, of course, is going to store everything for the complete journal log by itself. Okay, so you just press Q and you quit out of that. But maybe you want to look at something for a specific user, let's say. So we're going to do a specific service. In this case, what the U stands for would be the service that you're going to look for. So journalctl U, and then we'll do Zoom, let's say, because I know that we have Zoom running. So we press that. There's nothing for Zoom. So it is looking at the system D, right? So these are actually the kernel binaries. These are the kernel processes that are running. And Zoom is actually an application which is above the kernel. This is the Zoom process interacts with the kernel. So it actually does make sense that there's nothing as an entry for Zoom. So let's see if we can do journalctl, and let's see if we can do, I think it's called Zorg. That's not available either. So with the range of services, I'm going to try to see if I can actually find something that we can search for. So we have BIOS, we have APIC, we have FE. There's a lot of stuff that's available here. SM BIOS, we have TSC, we have ACPI. These are a variety of different services. I would say, I think these are the service names. So ACPI reserving, node data, zone ranges, movable zone. All of these things seem to be I don't think these are actually the messages. I don't think these are the services. So I'll just do ACPI as an example because that seems to be coming up pretty frequently. So let's see if we can find anything that has to do with the user ACPI, and still no entry. So I guess that's not the service itself, which is very interesting to me. So I wonder what would be considered a common service that would be running that we can search for. So let's go and see if we can find a common service to search for. Okay, so we got a couple of things. So let's see. SSHD for sure isn't going to work because I never did it. So shell is not here either. So let me do journalctl UFW. And the firewall isn't here either. It's interesting. There's like so many things that seem to be common services that I found on Google, but I guess because I never ran them, they wouldn't show up in my particular instance. So I'm gonna do journalctl, and I'm just gonna copy a couple of these lines and see what I can find for the given lines that I have here. So I'll just copy these lines, and then I'm gonna take it to my AI assistant and see what that can tell me. Okay, so to try to make our life easier, we're actually going to do systemctl, list units, and then we're going to look for the types of services that are running. And so here's what we got. We got the actual services that are running. And so we have ATD service, for example. So maybe that is one name that I can find with journalctl. So let's quit out of that, and we're going to do journalctl and do -u. And then we'll paste in here the ATD service. There we go. Finally, we were able to get some output here. And it only has 18 entries out of everything that's available. So finally, I was able to get something out of my journalctl. So it's actually very useful to know that one other command, which is the systemctl. So system control lists the units and the type of the unit, which is the services that are running. So systemctl list units type service will give us the list of all the services that are running. And then what we can do is we can use journalctl and then search for any given service, the individual service itself, and then we will be able to get that data. Finally, I was able to get something for that. Okay, so then we can search for the stuff that is running inside of this with the since command or the since option. So you can say since any given date, I want you to find what is going on this particular computer. So for example, yesterday, I believe was December 1st, right? Or yesterday is actually technically December 2nd. So I can say from 2024, 1201 until 2024 1202, give me a list of all of those, and then it will give me everything that falls in those date ranges, which is still obviously a very massive amount of data because this has been running for a few days. And of course, kernel services are constantly running all the time. So this is going to be a really big log. So this is it for journalctl. I'm not going to go too crazy. There's one thing that is actually very useful, which is to follow the log output in real time. So if we do journalctl and then do -f just by itself and press enter, now it's going to follow, and you can see on the left right here, it's actually updating in real time what's going on in my specific machine. And it's updating everything, I think, by the second, really. So this is one of the probably the most useful, which is journalctl-f. It actually follows the output of everything for systemd's logs in real time. And then we can really kind of just get, I mean, whatever. I don't know if you can make sense of this. I can't really make sense of most of this, but at least I know how to run it. That's kind of the big deal for me is just knowing the various commands and what I can do with them. And then whenever they need to be useful, they will become useful. For example, everything that I had to deal with partitioning earlier today finally became really useful when I was booting my Kali Linux from a USB drive and I had to establish my partitions and so on and so forth. So I knew of those commands previously. I had studied them, but then I never had to actually use them. And now I got a chance to use them. So it was very useful in that regard. Now we can do Control C in this case, and then we will end our live output of journalctl. And then finally, we can search for something from the logs, for example, error messages. Press enter, and then now we can see that the error of this agent is, yeah, what is it? So the error of this agent is reported first. So it's basically going to look for anything that has the word error in it, or ERR maybe even, or maybe that's been classified as an error. So because this one right here doesn't have ERR in it at all, so I can imagine that it's been classified as an error. So you can technically search for something using that P option. So let's go and look at the manual for journalctl to see what that P option is doing for us, because it's useful to know what it actually does. I have the command, the sample command here, but I do want to know what it actually does as well. So what do we got? P for priority. So I see the priority level of it is the error ERR. So ERR represents a priority level of 3. Critical would represent the priority level of 2, and an alert would be 1. And then we have emergency, which is a 0, meaning that you have to address this immediately. So maybe let's see if there's actually an emergent level priority that we need to address. So I will go over here, and then instead of doing that, I will do emerge. And thankfully, there are no entries that are emergent that I have to address. So that was it for journalctl, which is a very, very useful tool to look at the log entries for system D. Now, what we can go look at right now are the dmesg content. So dmesg is the kernel messages since boot. So if I just run this right here, press enter, now I got all the messages that have come from my kernel since I booted this computer 3 days ago. And of course, this is going to be a massive, massive list. I like the fact that it's color coded. It makes it a little bit easier on the eyes. So dmesg is what we got to be able to display all of the kernel ring buffer messages that we got primarily for hardware and boot logs, right? So that's what dmesg does. Everything that has to do with the buffer, primarily for the hardware as well as the boot itself. And then if I do dmesg and then pipe the response to that into the grep and then look for error, of course, I'm going to see a bunch of stuff for error in this particular case. And this is the mask error status for the mask, device error, correctable, all these things. I think it had to do with a lot of the issues that I was having with my partitioning, and I was trying to create the partitions, and then we went back and forth, especially during this training series, and we had several messages that were error messages that came up, and permission errors, and you can't function this, or we can't find this, and so on and so forth. So there were a lot of error messages that came up. So that could potentially have a lot to do with it as well. And then if we wanted to look at everything that was happening and just have a timestamp associated with it, we could just do the -T to display timestamps in a human readable format, which is what we can see over here. If we do the dmesg just by itself and then press enter, you can see the timestamp is actually not human readable format that we can see over here. So thankfully, there is a function that will allow us to do it in a human readable format, which is the T for the timestamps at the very least, that will allow us to do that. So if we do the manual page for dmesg, we can see that we have the print or control kernel ring buffer. So everything that's buffered inside of the kernel for the boot as well as the physical hard drive, the hardware stuff. So you can do C to clear the ring buffer if you wanted to. We can do the red clear to clear the ring buffer after printing its contents. So you could actually essentially clear it if you kind of trick the system. Hey, I loaded this, so it's fine. So you can now clear it after it's done with it, which would kind of make it a little bit, I would say, less populated. It would make it less noisy. So at the very least, it doesn't store as much data, and it would even free up some storage on your system, especially if you have a really busy system or you've kept it online for a long time. The human readable format is one of those things that I like a lot. So I'm going to run it one more time just to see what the human readable format looks like. Print of the kernel messages here. Again, so this is just, there's so many things that you can do over here. But the big key, the big takeaway is, as always, you need to know what it actually does. So dmesg in this particular case is going to print the kernel messages for buffers, anything that has to do with buffers. And the primary portion of that is for hardware and boot logs. And so one last piece, I want to see the human readable format, and it's nicely organized. Look at this. This is actually much nicer than what we had previously. So if we quit out of this, and then if we do dmesg and then do the H as well as the T, we will get the timestamps in human readable format, and everything else is also in human read. This is beautiful. Look at how nice this output is compared to what we previously had. And now we can just organize, go back and forth, right and left on our keyboard
with the right and left keys on the keyboard. So dmesg gives us the kernel buffer that has to do with boot as well as the hardware. Okay, to manage log file sizes, there's a command called log rotate, and this helps you automate the size of the files and how long they're kept and how frequently they should be rotated and deleted, so on and so forth. So log rotate is actually the command, and of course this has a manual for it as well. So manual of the log rotate. Description is that it's designed to ease administration of systems that generate large numbers of log files. It allows automatic rotation, compression, removal, and mailing of log files. Each log file may be handled daily, weekly, monthly, or when it grows too large. Normally, it is run on a daily cron job. It will not modify a log more than once in one day unless the criterion for that log is based on the log's size and log rotate is being run more than once each day, or unless the F or force option is used. So essentially what you can do is you can either schedule the rotation, the deletion, compression, removal, or even mailing of log files based on a schedule, or you can do those activities based on them getting to a certain size, which would typically happen when you have a very large machine or a large environment that has a lot of logs that are being generated. Now, what happens is that there is some kind of a configuration file that usually comes with this. So if we go ahead and list the stuff that's inside of our Etsy folder, if there is a configuration file, which there might not be, then we actually do have it. Excellent. So we have the log rotate configuration file. So let's see what is actually inside of the log rotate configuration file. So we can do the nano, and then actually I probably need to do sudo. So we're going to do sudo. Let's clear the screen so you can see the command sudo nano etsy log rotate that conf. And then this is it. So log rotate files weekly. This is what the current setting is. It's going to keep 4 weeks worth of backlogs. And then after that, it's going to probably delete it. Then it's going to create new empty log files. Oh, actually, so no, instead of deleting it, it's just going to create a new empty log file instead of deleting it. Using the date as the suffix has been commented out. Compression has been commented out. And it says include packages. So include the logrotate.d information into this directory. So these are the packages that will be included as a part of the log rotates functionality. So this is actually my current settings here. So weekly, rotate for, create new logs instead of deleting them or do anything else. And that's basically it. That's all she wrote here. There are a few other examples of what we can potentially do. So if you wanted to manually trigger that specific log rotate configuration, you can just do log rotate and then give it the location of its file, the configuration file, and then it would manually trigger it instead of waiting that 2 week period that it had, right? So you can manually trigger what it does, which means in my case, it would just create a new log file that was necessary for it. And then you can also run it in debug mode, which is kind of helpful as well. So log rotate.conf, that would run it inside of debug mode to see what would happen without actually rotating the log. So if we do this right now, we could actually run it and rotating parallel. So this is just in debug mode to see what would happen. And this is a massive output. So what I would do in this particular case, instead of doing this, because I do want to probably look at it later. So I would run the command. So let's clear this one more time. And then we would run this command and we would output it to log rotate, or let's say log r, and then report.txt, and then output that. Oh, let's see. It didn't even create it, did it? Oh, it did. It did created it. So it created the log r report, and now I can go into the log r report with nano. Oh no, it didn't create it. So interestingly enough, it created the actual text file, but it's an empty text file. It displayed it only on my screen. So I guess you can't actually view the log rotate debug report, or you can't export it, output that those contents inside of a text file. You literally have to look at it while it's on your screen as you run it like such here. It would basically look like this, and then you would have to analyze it like this to see if there are any errors or debugging or whatever it is. And this is probably the wet dream of some nerd that really, really likes looking at text and line items But if you really had to do some kind of troubleshooting, then that would probably be the best way to do it, is to run it in debug mode. There are some configuration examples that I do want to show you, and you probably just see it in the background right here. So this is the basic example of a configuration file for an application log. So we see that this is the location of the actual app, and then this will be the log that's being generated for it. So my app, and then any kind of log that is generated inside of this applications folder. This is what the asterisk represents. So it could be literally any log that's generated for this app. These are the rules for the configuration of that application's logs. It'll be a daily, so we'll go down here actually. It'll be a daily rotation of the logs. Every 7 days worth of logs are going to be kept, and then after that, it's going to compress the old logs. The delay of the compression until the next rotation is going to take place, so it won't compress the current specific log file until it's rotated next time. And then once it's rotated, then it's going to compress the current one that we're looking at. Missing, okay, so ignore if the log file is actually missing. Notify not if empty. So do not rotate if the log file is empty, which is very useful. And then create 0640 root, which means it's going to create the new log files with specific permissions in our particular case, meaning that it's as a root user as well as the root group. And then post rotate, so commands to run after the rotation, like reloading a service. So what do we have here is that the commands that we're going to run is the systemctl command is going to be reloaded, and then the my app service is going to be output into the dev null. So anything that may be unnecessary is going to be output into the dev null, like we did for a lot of our search commands where we got rid of the permission error messages because they were just too busy and they were taking up too much space. So all of the noise basically is going to be removed and it's going to be sent to the dev null. And that's basically it. That's what the configuration file for this, or configurations for this particular application's logs, will actually look like. And these are going to be included inside of the logrotate.conf. So you would actually include this at the bottom of the logrotate.configuration file, because this is where logrotate would go to run its scheduled rotation of the logs for this particular application. And then of course you can instantiate this manually. You can run it manually by just doing the log rotate and then giving it the path of the configuration file. And then you run that command and it will run it manually. And then it will rotate whatever the configurations are. Any of the configurations inside of that configuration file are going to be rotated. So that is it for log rotate. All right, our next section for monitoring our system is the system performance monitoring. And the way that we can do that with our first command is the VM statistics. So VM stat by itself. And then if we run it, it's just going to show us the VM statistics. So this is a little bit complicated to break down. And I will actually give you the best description that I can, because I know that I'm going to probably butcher a lot of this. So I'm going to copy this and I will show you what our friendly AI is going to explain for us. All right, so by looking at the columns that we have, right? So this is the first column, this is the next column, and everything under this column would be the swap, free, buff, cache. This is all falling under memory, and then you have the swap, and then you have the input, output, and then you have the system, and then you have the CPU. So by looking at these by columns, we can go down here and say, okay, so the processes column, the procs column, is going to say the number of processes that are waiting to run, so runnable or in the run queue. That would be it. So for us is going to be 3 are either running or in the run queue. Then you have the B, which is the number of processes in uninterruptible sleep, which are blocked technically, which means nothing. So we don't have anything that's been blocked. We just have 3 processes that are running. One of them would be the shell, I would venture to guess. The other one would be the Firefox, and then the other one would be Zoom. So we have these 3 processes that are currently running. The memory usage is SWPD, is the amount of virtual memory that's being used, which is our swap memory in our case. There is nothing being used in our swap space because we actually have very ample RAM on this particular machine. The free would be the amount of idle memory. And I want to say that there's a way that we can do this in human readable format, for example. So in this case, this is the number of bytes. So this would be 18 gigabytes, I want to say. And then you have the buffer, the amount of memory that's used as buffer, the amount of memory that's used as a cache, and we have that over here as well. And then we have the swap memory, the amount of memory swapped in from the disk, and the amount of memory swapped out to the disk. And both of those are zero because our swap memory usage is zero because we have ample amounts of RAM. And then we have input output. So the blocks that are received from a block device, which would be, we did our list of the block devices, and that would be our partitions, for example, and then blocks that are sent to a block device. And in this particular case, we had blocks that were received input, and then blocks that were sent output would be 109. So I would say that the 109 is actually the amount of stuff that I sent to my external hard drive. That's probably what we sent to the block device. The system would be the number of interrupts per second, including the clock itself, how many times it was interrupted, and the number of context switches per second. So the interrupts right here were 26, 24, and then the context switches were none, I think, or nine. The context switches were nine. This is kind of in a very weird format. I want to say, I think there's an actual way that we can do this in a summary as well. So if we do system performance S, so vmstat S, would give us the summary in this way. So this is a little bit more user-friendly, in my opinion. There might be a -H, just trying to guess. No, there is no -H. It's just giving us the help menu. So let me see. Is there human readable? There is no human readable. So just going back to the top right here, we're looking at the system, and then there were the interrupts as well as the number of context switches. And then you have the CPU usage. So the time spent running the actual user code. So user time, including the nice time that we just talked about, the priorities. So the time spent in the user code, which is 9 here, or no, wait. So this would be that, that 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 would be that. So 6 would be the amount of time spent on the user code. The SY would be the amount of times running system code, which for me would be 3. And then ID would be idle time, which is 91 because I walked away from the computer a lot and I just left it on. So it was an idle time for a very long time. The time spent for input and output was 0, interestingly enough. The time stolen from a virtual machine was 0 because we never used one. And then the guest time running a virtual CPU for guest operating systems was also 0. So we never did any of those things. So these are actually giving us the monitoring and system performance. So vmstat, as far as you're concerned, and if we looked at the manual for it and the description, it will report information about processes, memory, paging, block input, output, traps, so on and so forth, and the CPU. So it's giving you everything about your system, right? Your computer. It's giving you the processes running, the amount of CPU usage that they're actually doing, the amount of RAM memory that they're using, and the current number of processes that were actually running, which we saw for me was 3, and the amount of data that was sent into block devices or received from block devices, so on and so forth. So the first report produced gives the averages since the last reboot, and additional reports give information on a sampling period of the length of the delay. And the process and memory reports are instantaneous in either cases. And then we have the various options that we have. So we have display active and inactive memory. Give me the number of forks since boot, and this includes the fork, vfork, and clone system calls, and it's equivalent to the total number of tasks created. Then I have the stats, that which I did, then I gave you that kind of that vertical output. Display the header only once rather than periodically. And then partition devices, so detailed statistics about partition. So that would be interesting for us to look at. And then timestamps, and then the wide view, and so on and so forth. So let's just go look at partitions real quick before we move on to the next one, which would be the lowercase p here. So I will do q, I will do clear, and I will do vmstat, and I will do lowercase p. And it gives me information. Well, I guess it does. Oh, it requires a partition argument. So I do need to give it a partition argument. So we will do vmstat, lowercase p, and I will give it dev sdb1, I want to say. And that is the external drive that we have. So it's been read 6,733 times. it's been written to 48,000 times. And the requested writes is 28 million requested writes. That's insane. So I guess it's as long as it's plugged in, it's having constant communication with the external partition, which means there's literally 28 million requested times that it was requesting to write to the partition. So again, the VM stat based on what we have is giving us the information about our system, the processes that are running, the memory that they're using, so on and so forth. So that's what we got for VMstat. Then there's another one called iostat. And iostat gives us the CPU and input-output statistics since the last reboot. So if I run this, I love the fact that it's colors. I mean, honestly, anytime that it's not black and white, I just get so happy. So we have the disks, right? So we have SDA, SDB, and SDC, as we found earlier. And then there's the data that is available to us over here that I need to have explained because I don't want to give you horrible explanations. So let's go and consult with our AI. All right, so first we have the CPU statistics, which is at the very, very top right here. So the percentage of the user, meaning the percentage of the CPU utilized that occurred while executing user-level applications. In this case, 6%, 6.5% was user-level applications. The percentage of CPU utilization that occurred while executing user-level applications was a positive nice value, which would be low priority in this case, 0%. So there was nothing that I actually assigned a nice value to. There's the system, so percentage of utilization that occurred while executing system or kernel operations, which is 2.6%, rounding up from 2.59, obviously. And then we have I/O wait, so the percentage of the time that it was idle during which the system had outstanding disk I/O requests, which is 0.06, so it was technically idle 0.06% of the time since the last reboot. Steal would be the virtual CPU weights that were stolen, which is not available because we're not dealing with any hypervisor CPUs. And of course, the idle time, which is 90% of the time that this computer has been on because I was sleeping or I was going somewhere and I was doing something with my family, whatever it is. 90% of the time, this thing has been in idle because I never turned it off because I'm running Kali Linux from a live boot on a USB. And if I turn it off, I have to reconfigure everything so that I can start recording again. And I really don't want to do that. So then we have the device statistics that we have here. So TPS is the transactions per second. So the input output requests and everything that happened per second in our case would be what 1.36 on this particular loopback, 0.05 on the first disk, 0.43 on the second one, and then 0.11. So per second, I guess that kind of makes sense. So 1.36 per second on the actual loopback, and then everything else is broken down as it is. So we have kilobytes that are read, would be the amount of data that's been read from that device per second in kilobytes, and we can see that over here. So per second here, so on and so forth. And then we have the amount of data discarded per second in kilobytes, which for us, it wasn't much on everything else with the exception of what we discarded on the external drive. So 109 kilobytes per second were discarded on the external drive, although it's rarely used. For example, KB read, for me, it's not rarely used, obviously, because this particular disk is the external drive and I've deleted files from it, and probably it's lost some data from ended recordings that I didn't do properly or something. So KB read would be the total amount of data that's been read from the device, which in this part, actually, you know what? Just going back to this, there were a couple of recordings that while I ended recording, I closed out Zoom. Uh, and by the way, don't ask me why I'm using Zoom. I know there are other ways that we can do this, but again, I'm running this from a live boot on a USB thumb drive. Okay, so the amount of data, because I ended Zoom and the recording was being processed. So when you end Zoom and you process a recording, you have to wait a few minutes for whatever you were recording to actually be processed and saved. And there were a couple of times that I just stopped the processing because I didn't want to keep that recording. So that's probably data that's been discarded, which is why this value is actually so high. Kilobytes read, the total amount of data read from the device. Kilobytes written, the total amount of data written to the device, and then discarded in the kilobytes, all those rarely used. So we have kilobytes read, kilobytes written, and then kilobytes discarded, as we can see over here. Oh, this wasn't even the discarded. I was looking at discarded. This is kilobytes written per second. I'm so silly right now. I apologize. It's 3:20 in the morning. Please forgive me. And then that's all she wrote. So we have a lot of kilobytes that were written. So what do we have? Kilobytes in this particular case. It seems like 140 million kilobytes, which would be approximately what, like 14 gigabytes? I think it's been 14 gigabytes of data that's been written so far on this particular disk since I've been recording, which kind of makes sense. It sounds right. Sounds about right here. All right, so we can now clear this out. So that was the iostat command, just showing us the general CPU usage. We can do the extended statistics for us, for example, doing the iostat x and then do 1, and it will give us the extended statistics. And as you can see, this is actually updating in real time. And there was even a version of this that was available while we were running vmstat that I think I actually skipped over. So if I do vmstat 1, it will then also update this every 1 second and give me the usage of the system as well as the buffering and so on and so forth. And it's going to update it every 1 second for me. And then I can do vmstat 5 and it will update every 5 seconds, for instance, not to give me too much noise on my screen, so that it's still updating in real time. It's just doing it every 5 seconds. So vmstat and iostat can both be ran in real time. Iostat was the X and then 1, but I can do X3, for example, and then it will update every 3 seconds instead of updating every 1 second, and so on and so forth. So very, very cool that we can get system usage statistics very similar to what we run with top, and then we can see everything being updated in real time every second. We can actually do the same thing with the vmstat and iostat. And now that we have htop installed, I love the output of this as well because it's color coded and super organized. So this is another one of those things that we can look at the performance and what's going on with the computer in real time. So we got vmstat, we have iostat, we have top, and we have htop. And of course, we looked at the processes by looking at the process command. So far, we've covered a lot of good stuff by looking at system monitoring and seeing what's going on with our computer. So finally, let us move into the last subsection of system monitoring, which is just looking at a few of the other commands that we looked at the very, very beginning and just kind of reviewing those commands real quick. So getting ourselves some system status checks should actually be very healthy here. So doing uptime was one of the commands that we ran. The first time that I ran it, it was not up for a day. It was just up for like an hour or so. But now in this case, it's been up for at least a day and 11 hours and 53 minutes. 3 users, because I guess we created some users, so maybe that's what it is. And the average load time is available for us. So we can actually get the status check of our system to see how long it's been up and how many users have used it, so on and so forth. Excuse me. If I wanted to do this in a human readable format, I could just do uptime with the P, and then now it says it's been up for a day, 11 hours and 53 minutes. And that's basically it. That's all we got for uptime. It's fairly easy to check the status of the system using uptime. And then of course, I'm just going to show you what the manual looks like, because it's my habit to make sure that you understand that pretty much almost everything that we've run, with the exception of I think one command, everything that we've run has had a manual. And finally, we have the other command for checking the status of our system, which is going to be the free command. So it'll show the total used, free, shared, buff cache, and available memory. So we have the total memory used, and I actually like the human readable version of this. So let's do the human readable, excuse me. So it would be free dash h lowercase. So it actually gives you, instead of those large sets of numbers, it just says there was 31 gigabytes, 9 gigabytes used, free gigabytes 17, shared gigabytes, the buffer cache, and available memory. And this is for the RAM itself. So this is for the processing power of the computer. And then we can change the view that we get in a lot of different ways. So you can get the megabyte view, for example, which is where you see 31,000 megabytes, which would end up being 31 gigabytes. And you can modify this in a lot of different ways. I actually have gone through all of the different options of the free command at the very, very beginning of this training series. So I'm not going to go crazy with it. I will tell you where it is though. So if you want to go back and look at everything that we've done, it was in the, I want to say it was in the, let's see where it's located. Give me one quick second. It's definitely in section one, and I think it's under the memory usage. Yeah, it's under memory usage. So if you go to the very, very top of this training series, this training video for the command line, and you look at the memory usage portion, the memory usage timestamp, you will get a lot of various commands that we ran with free to look at all of the various data points that we can generate, kilobytes, kibi, mebi, gibi, so on and so forth, and then the human readable version, and then the wide version, counting to display all the results in count times, show the output on a single line, the seconds of delay for it to update in real time, displaying a line showing the columns, so on and so forth. So there's a lot of different ways that you can kind of customize your output in free just to see how much memory RAM usage is being done and the physical and swap memory of the system. And again, because of the fact that our system is actually pretty badass on this computer, we do not have any swap space that's been used. And it might probably be because of the fact that, I mean, I literally have I don't think I've even created a swap space on this particular thing because I don't need to. I have so much space available on my RAM, right? So processing power inside of the random access memory, I have so much space that's available. So free 17 gigabytes is available. So unless my computer starts slowing down drastically, I'm not even considering it. And that's basically it. That's the last command that we have for checking the performance of this particular system by doing some system status checks using the free command. And after this is done, which is actually we're done, so we can now move on to the very next section, the very big section that comes up, which falls under the package management section and all of the package installers and updaters and everything that we have for Linux.
This training series is sponsored by Hackaholics Anonymous. To get the supporting materials for this series, like the 900-page slideshow, the 200-page notes document, and all of the pre-made shell scripts, consider joining the agent tier of Hackaholics Anonymous. You'll also get monthly Python automations, exclusive content, and direct access to me via Discord. Join Hackaholics Anonymous today.
All right, so package management is done with the variety of package managers that are available on the different distributions of Linux. So for example, I am on a Debian distribution, which is Kali Linux. Debian and Ubuntu distributions of Kali Linux use the apt package manager. I like to call it for apt. That's what I typically refer to it as. And there's a series of commands that you can run. So for example, anytime that I wanted to go ahead and so actually we did it when we were in the scheduled tasks portion of this, where we had to install the at freaking scheduler, which never worked for us. So it's essentially sudo apt install yada yada yada. But typically what I like to do, and I've ran this already, so that's why I didn't do it when we were installing the at tool, is the first thing that you want to do is you want to update apt, and then it'll basically update all of the databases that is connected to. So conflicting distribution for Kali last snapshot release, yada yada yada, release file for this, so on and so forth. Updates for this will not be applied, and that's it. But for the most part, everything else was updated for us, so we'll actually go ahead and clear that out. And then you can do upgrade, so sudo apt upgrade. And what this will do is it's going to upgrade all of the installed packages to their latest versions. Now, this is going to take a lot of time for me to do, and I don't want to pause the recording. But essentially, update will update all of your databases so that you have the most recent repositories for apt to pull from, and then from there you can install whatever you need to install. And then if you want to just make sure that you upgrade everything that's on your system, you would just run the apt upgrade, and then it'll upgrade all of the packages that you have installed to their most recent versions. Now, if there's nothing that needs to be upgraded, it won't upgrade anything, but it's very useful because it'll actually check across your entire system. And if there's anything that does need to be upgraded to its most recent version, it'll actually go ahead and upgrade it for you. And then we have this sudo apt install, which is pretty much how you install packages. So it could be install at, it could be install, what was the htop, for example, is one of the things that we actually had to install. So that could be a command that you could run to install something or upgrade something. So sudo apt install would be the version of the command. And then there's sudo apt remove. And I actually want to remove the add package because that freaking thing was useless for us. So it says removing at, are you sure you want to do it? I am actually sure. So please go ahead and remove this freaking thing because it was absolutely useless. So that's how you remove something. And then sudo apt auto remove is actually a really powerful tool as well, or a version of the command. And it'll remove anything that hasn't been used. So for me, nothing, because again, this is a live boot of Kali Linux, and there was nothing that I installed inside of this session of the boot that I've had over the last 2 days. There was nothing that I installed that I never used. So it will remove anything that has not been used in a while, which is a really great way to clean up your system and get rid of any dependencies or any old specific packages that you're no longer using. So auto remove was a really, really good one. And then if you want to search for something, you can use the sudo apt search to see if there's anything, for example, that exists on your system with a certain keyword. So you can actually search for all of the packages on your system that have any given keyword in it. So for me, let's say Zoom, because I downloaded the Zoom player and then I installed it. And so now I have Zoom. But I guess these other things as well, and somewhere in their descriptions, there is the Zoom keyword that exists. So all of these other things have also been pulled up, which are not exactly what I was looking for. I was looking for the actual Zoom and Zoom player. So in this particular case, there's a bunch of shit that was pulled up that is irrelevant. Excuse my French. But for our case, we were able to prove the point that we wanted to prove. So, and then we have the final thing, which is sudo apt and then show the package name. So show me Zoom. And then now it's going to show the Zoom cloud services, and it's going to show all of the metadata for it. So for example, the 6.2.11 version, the status, it's been installed and it's all good. Priority is optional. The section is default, maintaining Zoom Linux team. Installed size 722 megabytes. The dependencies are all these things. And I had to actually install a lot of the dependencies for this by using sudo apt install and then giving it the list of the dependencies. So that was one of the things that I had to do with apt, and then the homepage for Zoom and so on and so forth. So these are the details of Zoom specifically, which is all good in our particular case. And so we can see over here that where am I? I feel like, am I still? Yeah, I am still inside this thing. So the recommendations, the mesa and all those things were all of the dependencies that needed to be installed. And unfortunately, those specific two that were at the very bottom, when I ran through the installation, they were not available. So those two were not installed. But thankfully, Zoom still works and it still runs for us. And we were able to record this entire training series. So that's been very, very nice. So that's basically it for the apt installer. And the apt installer is relevant to the Debian and the Ubuntu distributions of Linux. Okay, so I want to show you the other ones because I want you to be aware of them and I want you to know what they connect to. And this is, of course, in the lecture video, and then it's going to be inside of the notes and inside of the slideshow. So this information is available in the lecture, and it's available in all of the documents, the supporting documents that is available to the Hackaholics Anonymous Agents and Above group. So if you want to get that, you can definitely check out the link in the description below. But just wanted to kind of re-review that with you and just show that to you because you need to know what the different package installers are inside of these various distributions. So if you see a command like sudo apt install, and you want to know what it is, or sudo apt update versus sudo apt upgrade, you need to know what that is. And you need to know what apt in general is, and you need to know how to access the manual for apt and the various tools and resources and the options that it has available. So all of these things are very, very important for you to just recognize, okay? So apt is the package manager and the installer for Debian and Ubuntu. That's like the fourth time that I've said it. So you should know for the most part that that's exactly what it is. So now what we're going to do, I'm going to show you the other package managers for the other distributions. So just in case you missed the lecture, or in case you're not going to go to the lecture, at the very least, you know what the other package managers are. All right, so here we go. So we had apt and everything that we just talked about inside of apt. The next one is yum, which is the package manager for Red Hat distributions of Linux. So it would be Red Hat Enterprise Linux, it would be CentOS, and it would be Fedora. And these are the distributions that use yum, and essentially the same concept. So sudo yum update, sudo yum install, and the name of the package, sudo yum remove, and then sudo, I guess you don't need sudo to be able to search for something. So you can do yum search and then give it the search name, yum list install. So it will give you all of the installed packages that you have. And then yum info package name that will give you the info about any given package that you ask for it to provide. So yum is for Red Hat Enterprise Linux, which is also known as RHEL. So we can actually do this right here just to kind of make sure that you really get the visual here. They would be like that, and then that is RHEL, like that. And then there's CentOS, and then there's Fedora. So these are the various distributions that use the yum package installer. And then we have DNF, which is the package installer for Fedora and the newer Red Hat CentOS. So it could either be yum or it could be DNF that actually applies to these installations or these distributions. And it would be sudo DNF update, install, remove, search, list, and provide the file name, which gives you the which package provides a specific file, right? So this would be the series of commands that would apply to DNF, and DNF also applies to Fedora and the newer Red Hat distributions like CentOS and Red Hat Enterprise Linux. So both yum and DNF apply to Red Hat distributions of Linux, which again are RHEL, CentOS, and Fedora, and then Fedora, RHEL, and CentOS. So DNF and yum apply to both of those. And then we have zypper. So zypper is for open SUSE, open use. So I guess it's an open source use package manager. And this is kind of, I think it's outside of the scope. I'm not sure, but it was included in the notes. So I wanted to make sure that I included it in the lecture as well as what we're talking about here. So sudo zypper refresh would be equivalent to update. And then install the package name, remove the package name, search for a search term for those packages, info of the package name, and then list the updates that are available for your particular system. And refresh would be refreshing the meta repository data. It doesn't necessarily automatically update everything. You would have to probably update them yourself. But this is what is zypper, and it applies to OpenSUSE. And OpenSUSE is actually very interesting. So if we did a quick search, can we do a search inside of Linux like this? We can't. So what I'm going to do is I'm just going to do this, click right here, copy, go here and paste it. And let's see what OpenSUSE is. So OpenSUSE Linux. So OpenSUSE Linux is a free and open source. Let's zoom in here. It's a free and open source Linux distribution. Let me go here. Developed by OpenSUSE project. It's offered in two main variations, which is Tumbleweed and then Leap. And these are the release distributions, which is sourced by SUSE Linux. So that is it. That's what we have for OpenSUSE, I guess we can call it. And that's it. That's all the stuff that we have for package managers as far as what you can, the commands that you can run to update, to install, and work with a variety of different packages on your version of Linux, on your distribution of Linux. Now, the next thing that we can go over is working with the package files directly. So for Debian and Ubuntu, we are going to be using the dpackage tool to essentially not uninstall, but extract files and install them manually. So this is kind of the better way to show you this. So if I go to my contents of my desktop right here, or my user, so we are technically inside of my users folder for Kali. And you can see that I actually have this Debian installer file for Zoom that is downloaded here. And for me to be able to actually launch this and install this, the first time I thought that I was supposed to open it with the file manager. And so I went inside of the file manager here and I looked at what was available for my user, and then we can see that it's literally here. So let me kind of go full screen with this thing right here. We can see that it's at the bottom right here. So I do have Zoom all the way back at the bottom of this package list right here. And I opened this and I was like, okay, now I need to extract it, I guess. So it's going to open up the archive manager. And then I double clicked it and I was reading this thing. And then what it's going to try to do is it's going to show me the contents of it. And then when I saw the contents, I was like, okay, well, where's my install file? Like, how can I install this? And I tried to extract it using the extract button here. And I went back and forth a few times and I was like, oh my gosh, what am I doing? I'm such a freaking dork. I can't believe that I forgot that any kind of a install file inside of Linux is actually going to be installed with the package manager, or not the package manager. I guess this is, it is technically a package manager. What can I say? So it is a Debian-based package manager that will help you install something. So I ran the command and then I filled this right here with just the Zoom install file. And like a freaking charm, it installed Zoom for me. And it installed all of my shortcuts and all that stuff. So that was it. To install would be -I, and then you give it the package name for the install file and sudo dpackage, and then beautifully it'll install it for you. To remove it, you would do -R, and then you would give it the same package name, and it would remove the package for you. If you want to list all the installed packages, we can do dpackage-L. So let's do that, dpackage-L, and then it will list all of the stuff that has been installed for us. And of course, there's a lot of packages that have been installed on this computer. This is all in advance. So this is a lot of these things came pre-installed on this computer. This freaking thing right here, which was useless. We installed that and then we removed that in a few minutes ago. And then we have literally everything else that's available over here. And if I went all the way to the bottom to the Z letter, then I would be able to find the Zoom package that I also installed as well. So we can do the list version of this, not clean, excuse me, clear. We can do the list version by doing dpackage-L, and then we can do the package name to show the status of a package. So I can do dpackage-S, and then I will do @ for example, which is one of the packages that we had. And this has been deinstalled, right? So because we removed it with our apt package remover here. So that is gone. And then you can check the list of the files that have been installed by a package by doing L and then giving it the package name to list the files that were installed by it. So dpackage works with Debian and Ubuntu, and it's basically the service or the command, the tool that you would use to install packages, install package files that you've downloaded from the internet. And these are packages that are not available through the apt repository, for example. So if I go through the apt repository and I try to install Zoom by going to sudo apt install Zoom, it's not going to work. So I have to download the install file from the Zoom website. But because I'm using Linux, I'm going to be using the command line tool dpackage to install that Debian-based install file that I got from Linux. So this is what works for Debian and Ubuntu, which is dpackage. The next one is going to be for Red Hat Enterprise Linux and CentOS, and it's going to be RPM, which is the package manager, and the extension for those installation files are going to be .rpm. And so sudo rpm install the package right here would be to install the RPM package right here. And then the E flag will give you to remove the package. And then you have the Q and the A flags that will list all the installed packages. The QI flag, and then the name of the package that will show you the information about the package. And then the QL, the package name that will list all the files that are installed by that individual package. So RPM would be the package manager for Red Hat and CentOS that will help you install packages that you download from third-party websites, for example, Zoom. And instead of being zoom.deb, it'll be zoom.rpm because you're downloading it for the Red Hat or CentOS versions of Linux. And that's about it. That's all we got for the package installers for third-party packages. And now we can go into dealing with universal packages. Snap packages are also known as universal packages, and the command for this should run across every single distribution of Linux because, again, it's supposed to be a universal package. So you can do sudo snap install package name. So just to prove this theory, let's actually go into our command line and see if we can find the terminal for snap. So there is no snap manual entry, and snap has not been installed on my version of Linux, so I can actually install it as a package manager. And I don't want to do that because I already have the package. But it is a universal package manager that can work with, I would say, probably all of the various packages that you would need to install if from third parties, or the stuff that comes pre-configured with the repositories of Linux. So sudo snap install the package name, it'll actually install it for you. And then sudo snap remove the package name will remove the package for you. Snap list will list all of the installed packages for snap. Snap info package name will be the information about a specific snap package. And then snap refresh will update all the installed snap packages that you have on your system. So snap is the universal package installer, universal package manager. RPM is the package installer for Red Hat and CentOS, and dpackage is the package installer for Debian and Ubuntu. And again, if you see something like sudo dpackage I, the package name, you should know that I is essentially the install command for installing a package for Debian, and dpackage, as in a general term, is what's used to manage packages and work with install files, remove those packages, so on and so forth. So sudo dpackage or dpackage, anytime you see this, just think of package manager and installer. Anytime you see RPM, think of package manager and installer. And again, PM could be package manager, right? And then R would just be, let's say, Red Hat, for example. R could be the key acronym that you have for Red Hat to remind you that R would be Red Hat, PM would be package manager, and now you're dealing with an installer or a package manager for Red Hat and CentOS. And then we have Snap, which would be the universal package manager, which basically installs Snap packages, which are universal packages. And finally, we have the couple of tools that we have over here that are for apt as well as yum that will give us the searching of these packages that can be done with, of course, apt cache, and then the yum list that will basically list for you the packages that are available on your system. So let's actually go run this. So we'll do apt cache and then search, and then we'll search for something. So apt cache, search, and then search for Zoom. Look at that. There's a bunch of stuff. And then, of course, the very last line item is going to be Zoom itself. But then there's all these things that somewhere in the descriptions of these the metadata descriptions of all these different packages, the word Zoom probably exists. And you can rest assured that at the very least, you'll also find the one that you were searching for. For me, it was Zoom. So hopefully you'll be able to find what you were searching for as well. And if you do apt cache show the package name, it will actually give you the contents of the Zoom metadata. So we can look at this and then we can see, oh, look at this. This is the priority of it, the person that designed it. So where's the author? Can we find the author here? We can't, but we do find the vendor. So Zoom, the license is here, homepage is here. Installing this, you agree to the terms of service, so on and so forth. And these are all the dependencies, the recommendations, for example, and these are the dependencies here, description of the actual thing, the actual application itself, etc., etc., etc. So apt cache show Zoom will show you the data of the package, and then apt cache search will help you search for the package. And then, of course, I'm willing to get that there's actually, there we go. We have a manual for apt cache as well, which I don't think is going to give us much here. So there will be show, there will be search. There's the dependencies of the package that will show you what the dependencies are. The R dependencies, so each reverse dependency on a package, the package names that will be available for any prefix that you have to provide it. Dotty, which is takes a list of the packages on the command line and generates an output suitable for use by Dotty from graph visualization. Policy, so to help to debug issues relating to the preference files, Madison, etc., etc., etc. So these are all the various options that will come with apt cache. But just so you understand, apt cache performs a variety of operations on the apt package cache, and it does not manipulate the state of the system, but does provide operations to search and generate interesting output from the package metadata. So you're not interacting with the package in a sense that you would install it or uninstall it or update it or anything like that, but you are pulling information from the metadata of the package and manipulating the state or manipulating that data and providing for yourself interesting output. For example, getting the show package information or getting the stats of the package or getting the sources or yeah, the source show displays all the source package records, so on and so forth. So this is all about the data of the package that is available inside of the apt package cache. So that's what this individual item does. And then of course, yum list would pretty much offer the same exact thing, but it's for Red Hat and CentOS distributions of Linux. So yum list available lists all of your available package, list installed will list all the installed packages, and list search term will list the packages matching your search term. So these are the tools that we would use for searching for packages. All right, and we have arrived at our archiving and compression section, which is pretty much the last section before we actually jump into scripting, which is kind of I would say the most fun part of this whole thing because I really love automation. So archiving and compression, it's actually very simple and fairly easy to do. There are a few tools that are available to us to pull this off. The very first one is going to be the tar tool. Now, before I start doing it, let me actually show you the contents of my directory. So throughout our exercises today, we've done a variety of different creations. So we've created a bunch of different files, as you can see here. We've created a couple of directories, as you can see here. So now what we can do is using these various tools that we have for compression and archiving, we can actually start messing around with these files and directories that we have, and we can archive them and zip them and unzip them and unarchive them, so on and so forth. So the first one is going to be tar. So the tar command needs certain flags at the very least to be assigned to it. The very first one is going to be the C flag, meaning you're going to create an archive. The V flag is verbose, so it gives us a verbose output as it processes what it does and it creates everything that it does. And then the F flag is going to designate a file name that we are going to create as we do this. So let me actually do ls so I can kind of see what's going on here. So I will do tar and I'll do cv and I'll do f, and then the name of the directory or the name of the archive will end up being, let's say we'll do directories and then dot tar. Okay, so that'll be the name of our archive file. And then what we need to do is we need to give it the path to the directory that we want to actually archive. So in my particular case, I'm going to just take this directory right here because I know that this one actually has something in it. And then I'm going to archive that. So I will do directory right here, or maybe just to make sure that we are all good, we'll do dot to represent our current location / and then directory. And then we'll just give it like that, press enter. And it says, let's see, so directory file cannot open, permission denied. Oh, because I have the sudo permissions on here. So let's do sudo tar cvf and then directories or directory.tar. So we'll just do that. And then we'll do the / directory, enter, and there we go. Now it actually has archived the directory as well as the contents of the directory, and it's now sitting inside of this tar file that should be available on my desktop right now. And then we can see it right here. So directories.tar actually is here, and directory.tar is also here. So this initial one is created, but I'm willing to bet that it's empty. So this is actually a perfect use case for us to display the contents of that particular tar file. And we would do this with the tar T. So the T flag is what lists. So you can say list. You can kind of end it like that. So the T flag will list the contents. V would be for verbose. F would be the file name itself. And then we will give it the directories.tar. And then we'll see if there's anything in here. And there's actually nothing in here, right? So because we got an error and it wasn't able to process our specific requests. So it just created an empty archive for us. So the first thing that I want to do is I'm just going to remove that directories.tar file and clear this up. and do ls, and now we should only have one, which we do. So that is our directory.tar archive. And now I can go ahead and list the contents of that by doing tvf. So list verbose file and then directory.tar, press enter. And now we can actually see the contents of that directory, which is the directory folder, and then the files that are also included in it. So beautifully done. We actually have been able to create our very first archive. So I'm going to go ahead and clear that up. And now what I want to do is I want to extract the contents of it, right? So first we were able to create it, and now we want to extract the contents of that directory. So what I can go do over here would be to do tar, and then we're going to do the X flag for extract, and then the V flag for verbose, F for the actual file name that we want to go ahead and extract here, and then we're going to do directory.tar, boom, and now it's done. Oh, again, I wasn't able to do it because I didn't use the sudo command, so I wonder if it actually pulled it out, and it seems like it did not pull it out. So let's just check and let's list the directory content. So we have file2 and file.txt that are in there that still have not been extra, or they're still in there. So I would say, and we haven't duplicated anything, I don't think. So what I'm going to do is I'm going to do sudo tar, and I'm going to do extract verbose, and then we'll do the directory.tar. And then now we've done it. So clear that, ls, and now we have the directory here. And there it is. So if we were to see if this actually worked, so let's try to do this. List the contents here, and let's see. And it's still there. So there has to be a better way that I can manage this and try to confirm that everything's being done. So what I'm going to do is I'm going to remove the directory.tar to clear up our desktop, okay? And then from here, what we're going to do is we're going to run our tar command one more time to actually create that directory.tar from the directory, okay? So now we have that, and now we have this directory right here. And what we're going to do now is we're going to display it by doing the tvf and then give it the directory tar to make sure that it's there. Okay, so there we go. We have that. So now to actually kind of do some little strategies here, dir2 is actually empty, and ls for dir3 is also empty. So if we actually go to dir2, we literally have nothing in it. So we are going to rest assured that there's literally cd. There we go. So we can rest assured that if we remove the dir2 and dir3, pretty much nothing is going to happen. But the directory that I have over here actually does have contents here. So if I do a list of that directory, we can see that there are two files that are inside of it. So now here's where we're kind of gonna risk everything, right? So I'm gonna go ahead and sudo remove and then do a recursive remove of everything that is inside of that directory. And now I have no longer a directory that is available here. So now I need to extract the contents of our archive file. So we're going to do the tar xvf. Actually, let's do the sudo to make sure that it's good. And then we're going to do sudo. Then we're going to do tar xvf. And then we're going to give it the name of our archive, which is directory.tar. And that's done. So and there it is. So it actually did extract what we were looking for, because it is now, as we can see, back in our current location. So there we go. That's how you can extract it, but it doesn't delete the actual archive itself, which is kind of helpful actually. So instead of deleting the compressed folder, which typically I don't think anything does that. So okay, so that's what we got. So sudo remove, and then we're going to remove the directory archive here, and we are back to our original location. So that's how you create an archive file, how you list the contents of it, and how you delete it, okay? So now we can create a zip file using the same tar command. So we can do something like sudo tar cvzf, because now we're creating in verbose, and we're going to create a zip file. That's what the Z represents. And now we do need to give it a file name. So what I want to try this time around is I want to give it multiple files to put inside of this particular zip file that I have over here. So what I'm going to do is I'm going to give it the, let's see, we'll do file2.txt, and then we'll do file.txt, and then we'll do message.txt. Let's see if that works. So these are the files that we're going to actually back up, and I need to actually dedicate the file name first. So these are going to be files dot the extension for this would be tar.gz. That's what the extension is going to look like. So we're going to create a backup file called files.tar.gz, and it's going to include, hopefully, these three files that we have over here. And let's press enter. And it seems like it worked. So let's clear that up. Let's see what we have. And there it is. So let's now list the contents of it. So we want to do tvf and then give the files.tar.gz. And there they are. So it actually worked. We were able to archive multiple files inside of that particular zip file. So to now rest assured that we actually have done it, and again, risk it one more time. What I'm going to do is I'm going to remove the file2.txt. I will remove file3 or file.txt, and I will remove the message.txt. And let's list, and we no longer have those items that are over there. So what we're going to do now is we're going to extract the contents of our zip file by doing the extract. Again, just include that z flag in there, and then give it the files.tar.gz. Press enter. It says that it worked. Let's run ls, and they are back. So the files that we did delete are actually back here as well. So this is actually working perfectly. So now we can go ahead and remove our files.tar.gz and clear that up. And here we are again, back to base status. So we've created a tar archive. We've created a zip with gzip. So that's what that last command was. We created a zip file, zip archive with gzip. There's something called bzip. So B as in boy, bzip2. And we can go ahead and create another archive with that. So CVJF would be the flags to be able to create a bzip file. And again, we would just give it a files.tar.bz2 would be the extension of this thing. And then we would give it all the files that we want to back up. So file2.txt, file.txt, file3.txt, message. Let's just take everything, right? Message.txt, message2.txt, num.txt, and sort.txt. We'll take all of those and we're going to create this. Now I need to, again, I almost forgot, and it would give me an error message, and I would need to do all of this all over again. So I need to put a sudo at the beginning of this. So there we go, sudo tar, press enter, and it has now completed it. So let's go look at that. And we do have our files location. So here it is, right? Sudo tar list the files for .bz2 here, and we actually do have them in there, so we know that the archive does exist, which means that I can rest assured and I can remove everything. So I can remove file2.txt, file.txt, file3.txt, message2.txt, message.txt, num.txt, and sort.txt. I can remove all of those, clear it up, and now our location is empty. So what we're going to do is now we're going to unarchive what we got. So xvj, I think that's what it was, right? xvjf. Yeah, that's how we can extract this particular one. So it's going to be the files.tar.bz2, enter, and clear and listed. And there are all of our files again. So beautifully done. So now we can do sudo remove of the files tar.bz2, and that is now gone. So there is yet another version of a archive zip file that we can create, and that is the XZ version. So we can, I mean, pretty much the same process, right? Create in a verbose output, give me a capital J to give me the XZ, and then an F for the file name that we're going to declare. It's going to be files.tar.xz in this particular case. And then for this, I'm just going to do file.txt and I'll do file3.txt and that's it. We'll just do that and they've been done. So now we have file.txt and file3. So we can, again, just go ahead and list them. So tvf files.tar.xz, and there they are, file and file3. So I can remove file.txt as well as file3.txt to kind of increase the risk a little bit here. And then so we're going to do sudo and we're going to do tar. We're going to extract v capital J F, and then we're going to give files.tar.xz, and there they go, and there they are again. They're back here. So the tar command will create a tape archive for you, and you can do a compressed version of it by creating a zip file, or you can just do a regular archive file by just doing the files.tar, by just doing the sudo tar. And then I have to do sudo because I've messed around with my permissions a little bit, so I can't archive something that doesn't belong to my root user. But typically, for the most part, you shouldn't need to run sudo for this. And then you would do C to create it, you do V for verbose output, and at the very least you would give F to give the name of the archive file that you want to have, and then you would give it the name files.tar, for example, and then you would take file2.txt and then file3.txt and archive it, and there you go. And now you have these two files. So you can create a regular tape archive, or you can create some kind of a zip archive file, and you can do that accordingly with the various flags that we just discussed. So I'm going to do a little bit of house cleaning here, and I'm going to remove these tar files that we have here, and then we're going to move to the next zip file creation commands that we have, which are going to be gzip, which is actually a really popular one as well, and then gunzip, and then there is zip, and then of course unzip. So these are the various commands that we have for creating zip files and then unzipping them, so to speak. Okay, so gzip is a much simpler version of what we just did, where we can create some kind of a zip file, basically compress something. So let's go back here and we have the ls, so we can do gzip and then we'll do file2.txt, and now we have a zipped version of it. So you can see it, file2.txt.gz. If I wanted to unzip it, I would technically do gunzip, or I like to call it gunzip. So I can just do gunzip, and then I will do file2.txt.gz, and then it will unzip it for me. And what's nice about it is that it'll also remove it. So it'll just unzip it and then remove it. Then you have the next command that would be the keeping of the original. So technically, if I wanted to, and I can actually decompress a file as well. So if I did gzip one more time, so if I did gzip and then I will do file3.txt, it'll do it for me, but you can see that file3.txt is actually gone, okay? So I can do gzip d and then do file3.txt gz, which is the decompressing of this file, which acts exactly as the same as gunzip or gunzip would. So there we go, and then we list it, and now we have file3.txt back here. So what it does is that when you run this command, it actually takes the original file and just puts it inside a compressed file, which is really nice because now it's not confusing. But for some reason, let's say you want to actually keep that original file available here as well. So you can do gzip, and then you can do the K for keep, and then you would do file3.txt, and it would create that zip file for you, but then it would also keep the original file over here as well. So in this particular case, I don't need to unzip it because I actually have my original file as well. You can unzip with the gzip -d command for decompress, or you can just unzip by using gunzip and then give it the name of the file, the zip file, and then it'll do that for you. And then what can happen is that if you wanted to, for example, let's say if I wanted to unzip this file3 right here, if I wanted to unzip this, but then assign it to a new file name. So I want to keep this file3 just so I don't get confused. I want to unzip this and I want to assign a new file name. I can do gunzip and then C, the C option, and then we will give it the file name that we're going to decompress here, which is the txt.gz. And then from here, we're going to do our greater than symbol, and then we're going to give a new file name. So it will be file4.txt, for example, and do that and run ls. And now we can see that we have the original file, we have the zip file, and then now we have the new file4.txt as well. But now I have extra files on this freaking desktop. I'm just running out of, there's so much freaking files that I have over here. So we're going to remove the file3.txt.gz. We're going to remove file4.txt. I'll also remove file2.txt just to make it a little bit easier for my life. And now I should have a few less number of files to deal with. And let's just remove this file3.txt over here too. So there we go. There we go. All right, cool. So we have done gzip, we have done gunzip, which is also cool to say as gunzip. And then the next one is going to be zip and then unzip. So a very, I mean, it's all kind of coming together. As you can imagine, there's a lot of ways that you can zip and unzip files. So zip archive name in this particular case would end up being, let's say, files.zip, and then we would give it the files that we want to zip in there. So we would be, let's say, file.txt and then message2.txt, for example, press enter. And now it's added, everything's all good. Clear that up and we'll list it. And then we can see that we actually have our zip file. And if I wanted to unzip it, I would just do unzip. And then I would go ahead and give it the files.zip and then it would unzip it. What do you want to replace the files? Yes, no, all. I do want to replace the files, and I do want to replace that as well, just so I don't have duplicates here. And there we go. So we've unzipped it, and we've just replaced the originals. So there you go. And we're going to remove the zip file. Cool. So that was it for zip. We can create a zip archive of a directory recursively by using the zip with the R command, with the R option, which is for recursive. And then I can go ahead and take our directory, for example, and then zip that. Nothing to do, directory. Oh, I see. I have to give it a zip name as well. I forgot to give it a zip name. So let's clear this up. And then there we go. So we do zip, and then we do R. And then what we're going to do, first of all, is we're going to give the directory.zip file name, and then we're going to give it the path to the directory, which is this thing right here. And then it's going to do it. So permission denied because I didn't run it with sudo. God bless America. So here we go. Sudo, boom, and now it's done. So it's updated and it's added everything and it's all good. So if we list it, now we actually have a directory.zip file available for us. And then if we wanted to encrypt it, which is a very cool little tool that we can use as well, we can do sudo and then do E for encryption, or I guess if I'm not dealing with the directory file, because this is the only thing that requires a sudo permission, I could just do zip and I could do E for encryption, and then I can take files.zip here and I can take .txt, or I think that might have sudo permission. So we'll do file.txt and message.txt and zip those. Password, look at that. We actually give it a password to encrypt it, and now it's been encrypted. And look at that. So we have the files.zip. And so if I wanted to unzip this, guess what? It's going to ask me for the password. And now I've done it, replace them. Yes, I want to replace all of them. Yes, I want to, or what is it? A, there we go. There we go. Infiltrate, boom. And now we have all these things. So very cool, right? I really honestly like the fact that we can encrypt them. That was one of my favorite things so far about these zipping exercises that we have done. So that's what it was for zipping and unzipping. You can also obviously list the contents of a file doing unzip-L to list the contents of that zip file. And then we can, of course, unarchive it or unzip it to a new location by assigning the dedicated location to it. So one more time, if we do a sudo zip and then do recursive and then do the directory.zip and then assign the directory to it, we have this new zip file here. And if I want to sudo unzip this thing, but I want to put that directory.zip file in a new location. So let's say I will actually put it inside of my dir2 directory that I have over here, and I will go ahead and extract it to that location, and file name not matched, which is dir2. So let me see. I do have dir2. I don't know why it's saying that I don't have dir2. So we'll run that one more time, except maybe I'll just remove that piece right there and do that. file name not match. That's so interesting. I literally have dir2 like right there. That's so weird. I don't know why it's not working. So let me just make sure I'm running it right. Oh, you know what? Whoops. I have to do the -d command to dedicate the new directory. That's what it was. That's what it was missing. So now it's going to unzip the contents of that directory, zip file inside of the dir2. There we go. Perfectly done. And now we have the ls of the dir2, which includes the original directory file or folder that we just unzipped into it, and beautifully done. We were able to pull that off. So we are going to take the directories.zip file, remove it, and we are back to base state. So that was it for zip and unzip. And finally, we have a couple of other tools that we can use for compression, which, I'm not going to give you all of the individual commands of this because you can kind of get the gist, I feel like. So it would be bzip2, which is what we actually did when we created the tar files. So we were actually using a bz2, which I believe is the bzip extension, and we were able to create, yeah, bz2 exactly is what we done already. So bzip what we did with the tar archive tool, but you can just use bzip2 manually to actually create the compression for yourself. So it could be anything. So let's do file.txt, and we will go ahead, and there we go. It gave us the file.txt with the bz2. The difference here is that it's not .txt .tar .bz2. It's just .bz2 at the end of it. And if you wanted to compress it while keeping the original, it would be bzip 2 and then with the K command or the K option, which we already have dealt with. And if you want to decompress it, we would just do -d and then file.txt.bz2. And now we have decompressed it, and there it is back to its original state. B decompressing is the same as b unzip 2, by the way. So if you have created the bzip 2 and then we did the file, well, actually, we did the file.txt and we've created that. If we wanted to decompress it, instead of doing bzip2 with the D flag, we could just do b unzip and then give it the file.txt.bz2, and then it would unzip for you. Or b unzip. Have I b unzip 2, right? Isn't that what it is? So let me make sure I have the file right here. So it's b unzip 2. Yeah, and then give it the actual file name, which is going to be file.txt.bz2. Boom, there you go. Okay, now it worked. I think I didn't add the 2 at the end of that one. So there you go. That's how it works. And you can, of course, assign a new file name as well by doing b unzip 2 and then c, and then this will be the file that, for example, file.txt.bz2 was the archive file or the zipped file, and then we would give the greater than symbol, and then the new file name is where it would go if we wanted to uncompress it or decompress it and assign it to a new file name while keeping the original. So that is what it is for bzip2, and then bunzip2 are also known as bunzip2. And then, of course, we have XZ, which was another one of the tools that we used or another one of the compression styles that we used when we were doing the tar archives, the tape archives. And so that is XZ. And then you can just use the file.txt. And now you've created a zipped file of that. Of course, it doesn't keep the original file. It just turns that file into a zipped file. So if we wanted to keep it, we would do XZ, and then we would do the -k to keep the original file name. So in our particular case, let me make sure. So I would do XZ, and then I have for example, the K, and I would do num.txt. And now I have the original file as well as the zipped version of the file. And then if I wanted to unzip with them, I would just do decompress, right? So -d stands for decompressing everything. And then we would just be able to decompress everything that we have here. So XZ will do decompress of file.txt.xz, and we will also decompress number.txt.xz. And there we go. Everything, the number.txt actually already exists. So I guess that's an error that it's giving me because it doesn't want to replace that original file. So sudo remove num.txt here. And then what we're going to do is going to do xz decompress of the num.txt, and then boom. There we go. And that's it. We are officially done with everything with the exception of our shell scripting section. And that by itself is going to be a whole other animal. So I'm going to wrap it for tonight. It is 4:45 a.m. as I'm recording this. So the sun is about to come out and I'm about to go to sleep. So it's been a very, very long night for me. So hopefully so far you've gotten a lot of value out of it. And we're about to hop into the very last section of this whole thing, which is all about shell scripting. And then we're going to wrap it up and you will be officially done. If you did this in one sitting, if you went through this entire tutorial in one sitting, I give you mad props and I'm very, very proud of you. But in case you haven't done that, and you did it in multiple settings like I did, then that's all good too, because most likely this is going to be several hours of recordings. So hopefully so far you've gotten a lot of value out of it. You've learned a lot. And now we're just going to go into the last section and wrap this whole bad boy up. So let's go into shell scripting.
This training series is sponsored by Hackaholics Anonymous. To get the supporting materials for this series, like the 900-page slideshow, the 200-page notes document, and all of the pre-made shell scripts, consider joining the agent tier of Hackaholics Anonymous. You'll also get monthly Python automations, exclusive content, and direct access to me via Discord. Join Hackaholics Anonymous today.